In example 2, this question says solve this equation, and it also says verify the solution. One thing that we're going to add to our steps is a step 4, which is to verify, because we're going to find out in our next example that you could get something called an extraneous root. So verify is you're going to check for extraneous, very fun word, roots. What that means is an answer that appears to be an answer, but when you actually check the answer, it doesn't work. So we do all the algebra that we're supposed to. Isolate the square root, square both sides, then we solve for x, and we get an answer for x, but when we check that answer by plugging it back into the original equation, it doesn't work. So the way that we verify or check for extraneous roots is we plug all of our answers back So we'll plug all of our answers back into the original equation. In particular, we're going to find out that things won't work when we have the square root of a negative number. So we get an answer that appears to work, but when we actually check it, it's causing us to take a square root of a negative number. So we're going to see if that happens in this case or if the answer that we get works. Now this question has two square roots. It's got a square root of x on one side, a square root of x on the other side. I hope you can see that those are like radicals. So we're going to isolate the square root first. We're going to combine our radicals. Can you see that if I subtracted 4 root x on both sides, that would leave me with 3 equals 1 square root of x. Still have a plus 1 there. My radical isn't isolated yet. Subtract 1 on both sides. And I get 2 is equal to the square root of x. That's an ugly looking x. Now we can square both sides. And we get 4 equals to x. If we want to check or verify, the way that you check, the way that you set it up, is you take your original equation and you draw a line down the middle where the equal side is. This is the left side. This is the right side of our original equation. Our original equation had 4 square root of x, and we're going to check by plugging in 4 for x plus 3. And our right side said 5 square root of x. I'll plug in 4 for x plus 1. So we're going to check, what is this equal to? 4 times 2 is 8. Plus 3, this side is equal to 11. 5 times 2 is 10. Plus 1, this side is equal to 11. So with our check, it worked on both sides, so we know that this is the answer. And that that answer works. Questions 7 and 9 for practice.